Hello everyone, I'm Jing Wang from Northwestern University. It's a great pleasure today to talk about our walk and learn work on facial attribute learning from egocentric video and contextual data. This is a collaborated work together with Yu Chen and Rogerio Ferris from IBM T.J. Watson Center. So, attribute-based analysis actually provide us with shared properties across either objects or people, and describing people based on their semantic attributes like clothing and eyewears and hairstyles is important in many applications. For example, the clothing attributes forms a powerful feature representation in clothing retrieval and fashion tendency analysis. And many criminal investigation processes involve searching people based on their fine-grained attributes. In addition to suspect investigation, attribute-based people search system can be used in searching missing people as a complement to face retrieval system. Among all the attribute description, the facial attributes actually provide us with the dominant information in describing a certain kind of face in a crowd of candidates. So in our target searching, with more and more detailed attributes coming up together, the searching results would become clearer and more similar with each other. And these attributes can be further categorized into identity-related and non-identity-related. The identity-related attributes could be the gender, ethnicity, and age. And non-identity-related could be your hair color and facial accessories and even your facial expression. So the learning of facial attributes actually initially relies on the handcrafted feature, which turned out to be unsuitable for uncontrolled environments when there are larger variations in background clutters and varying poses of subjects. And the prospects of deep learning network provides us with new ideas about deep attribute modeling based on fine-tuning. Researchers worked on several CNN models by learning part-based features with pose alignment in 2014 on general attribute learning, and later, to gain better performance in the identity-related attribute features, pre-trained model for face identification was proposed on a cascade of CNN model in 2015. And this result turned out to be very good, but the problem is the face identification in the pre-training stage would require massive amount of identity labeled data, and such identification would tend to ignore some non-identity related facial attributes like your facial accessory. So this raises a question if we are able to acquire the attribute-related feature in the pre-training stage without requiring the manual annotation on person's identity information. So given videos of casual walker, we are able to extract a massive amount of face tracks. Although it's hard to determine the identity of a specific face in one frame, we're able to use the temporal and geolocation constraints to determine if two faces are from the same person or not. For example, the two detected faces in one frame can generally from different persons, right? And the two faces in one facial checks are generally from one person. So we are converting the problem of identification, which requires manual annotations, to an easier problem of verification problem, where the labels can be easily obtained from the facial checks. And in addition to the verification information we could get, we are thinking to rely on some contextual information could be helpful in the facial attribute feature learning. And our observation is some facial attributes are highly dependent on the geolocation and weather. For example, the ethnicity-related features attributes are highly dependent on where the images are captured, and the weather would affect the facial accessories and outfits of the worker. So we are thinking of leveraging the contextual data as a source of weak labels to help us learn the features which are suitable for the facial attributes. And then our goal is to develop a self-supervised learning approach to model the facial attributes without manual annotation in the pre-training stage. Ahead of that, we need to construct a large dataset of casual walker from the egocentric videos with the corresponding contextual information. Our egocentric video collection actually covers different neighborhoods of New York City. This figure shows ethnicity distribution map together with census data. And the different color actually represents the dominant ethnicity group in the specific place. In our video collection, we select the different regions with the different dominant ethnicity group. Together with the video, we use a GPS sensor to record the location and the detailed weather condition using an open weather API. After all the collection, we discretize the contextual data into discrete labels. The GPS coordinates are clustered based on the census map, and the weathers are grouped into hot and sunny, cold and cloudy. So after nearly 2 months from late summer to fall, 25 days collection, we are able to collect over 40 hours of egocentric videos containing 160,000 faces, altogether generated 4.9 million of face pairs. And these images are actually rich in variations of poses, lighting condition, and covering different locations and in varying resolution, which we consider might be a complement to images on the web. And our self-supervised pre-training part first focus on face verification in constructing a semis structure by minimizing contrastive loss on facial verification. At the same time, we would like to learn the high-level features from contextual information. So we train the weather and location classification model independently by minimizing their own softmax function. And these two contextual model are initialized by the weights from the verification trained model on the bottom layer and fine-tuned with their individual contextual labels. After we've got these three pre-training models, we concatenate the features extracted from the top layer and to form the final model in our fine-tuning with attribute labeled data. And here our inputs are the images together with multiple facial attributes. And this multitask learning problem, we minimize the cross entropy loss function to implement this multitask problem. And to evaluate our effectiveness of each component of our network, we first tested on an attribute dataset collected from 25 egocentric video, and each image in this dataset contains 17 facial attributes and has large variation in different conditions of lightings and poses. We first evaluate the model fine-tuned from face verification with training from scratch, and the overall improvements demonstrate that the richness of our verification model obtained from the unlabeled egocentric videos. And when we add on the different components of our contextual model, the precision of the attributes has been improved progressively in different aspects. The geolocation model puts more weight on the location-related ethnicity attributes like the East Asian and South Asian, and the weather model adds in weight on non-identity related but weather related attributes. And the combination of the both weather and geolocation gains the best performance. And to further determine if our pre-trained contextual model has learned attribute-related feature, we show some qualitative examples of visual attributes discovered in the pre-training stage. The images shown on the first row are selected by the top 9 activated neurons in the top layer in each location class. We can see that the images are almost from different races, and that means the neurons in the location model are learning strong prior about the concept of ethnicity in their location classification learning. And the bottom row shows the visualized features of the top 9 neurons of the top layer of the pre-training and the corresponding images. The local visualization of these neurons successfully captured the local attributes like hat and sunglasses, which demonstrate the weather model provides the complementary features on the non-identity related but weather related facial feature. And please refer to our paper for more visualization examples. And we further test our method on two standard facial attribute datasets, SLAP-A and LFWA. Each dataset contains 40 attributes with binary annotation on either identity-related part and non-identity-related part. And we compare our method with full state-of-art methods, Face Tracer, which relies on handcrafted features, and two versions of Panda, which relying on part-based pose alignment. And LNet and plus ANet is utilizing face identification with manual annotations in their pre-training stage. And we can see that our method gains comparable results in LFWA and outperforms the previous results. So in conclusion, we established an ego-human dataset of casual workers which contains rich facial attributes and associated with the location and weather contextual information. And we developed a self-supervised approach to leverage the discretized data as weak label and to acquire attribute-related feature in pre-training. And we believe that our work offers novel ways to learn rich facial representation from the ever-growing pooling a pool of the unlabeled egocentric video with contextual data. And we think that by learning with diverse contextual information, such framework could be also applied to other high-level analysis tasks like clothing and scene attribute analysis. And this is the end of this talk, and you are welcome to drop by our poster to have more discussion. Thank you.